Alrighty. Well, good morning. I hope you guys are doing well, and that your morning started well, that your first period class was all right. Today we're going to be doing our practice activity. Hopefully it works. I had some issues with Pear Deck on period 1. I set this up to be a Pear Deck activity. So if you're having issues with the activity, please tell me so I can try and fix it or think of something different. I'm not sure why Pear Deck's being difficult this morning, with me at least. So we're going to be doing that for section 8.3 today. Get some little practice problems in, answer your guys' questions. Yeah, and then that will wrap up chapter 8. The assessments are almost all done. Multiple choice assessment is posted. The free response assessment and self-assessment is being completed right now. I'm almost done. I'm like halfway done writing it up, getting it all nice and pretty for you guys. Yeah, and then we'll be moving on to chapter 9. So good times. All right, so yeah, we'll get started. Let's cross my fingers. Hope the Pear Deck cooperates with me this class period. And hopefully it is useful. So let's do this and that. Alright, so here is my Pear Deck screen. I'm also going to copy this link and drop it in the chat here. So you guys can join through the link, or you can go to joinpd.com and go to BQYNHS as the class code and join that way. Keep in mind, this is your opportunity to practice and review the content that we learned about yesterday, and hopefully help you get a little more confident in how these things work. So please take a moment, join the course, and we'll get started in a couple of minutes. So here we go. We're doing section 8.3, estimating population mean. This is the final section of chapter 8 with estimating with confidence. All right. Our first slide here is a review of the key concepts. All right. So if you don't have anything else in your notes for section 8.3, you should at least have these things. These are kind of the big takeaways from that section, things that you need to use, things that you need to be able to apply. Right, we have our conditions for constructing a confidence interval about a mean. We must check that it is random. We need to check the 10% condition when sampling without replacement, which is typically the type of sampling that we're doing. And we need to check the normal large sample condition, meaning either the parent population we need to know that it's normally distributed, or our sample needs to be large enough, meaning greater than 30, greater than or equal to 30. If neither of those things happen, then we need to check the shape and the normality of the sample distribution by looking at a dot plot or box plot, histogram, something that shows us the distribution shape, and check to make sure that it is not really skewed and that there's no apparent outliers. Right, so those are the conditions we check. Our inference method that we learned was the one sample t interval for a population mean. It's very similar to the one sample z interval for a population proportion. Right, when the conditions are met, a C% confidence interval for the unknown mean mu is given by the formula here. X bar plus or minus t star times s sub x divided by square root of n, where t star is the critical value for the t(n minus 1) distribution, right? That's the degree of freedom, t(n minus 1), with C% of the area between negative t star and t star. All right. we then have choosing a sample size for a desired margin of error. Right? We have to follow these steps. We need to have a reasonable value for the population standard deviation from an earlier study, right? Either from a, some sample that we have data for already, or a previous result that we're provided with. If we do not have something to use for standard deviation, we cannot, choose a sample size. That's just the way it is with the means. We need to find a critical value z star from a standard normal curve, meaning we go back to table A, right? Our t interval, table B, choosing a sample size, table A. Right? So when choosing a sample size and solving for n in this scenario, we're always using table A. Right? We find that critical value z star. We're going to solve the inequality for margin of error for n. We use that z star times sigma, or whatever standard deviation you get to use, divided by the square root of n is less than or equal to the margin of error. Lastly, whether we're dealing with a confidence interval for a mean or a proportion, we use the four-step process. Right? And this is essentially our roadmap to make sure we cover all our bases and gives us the best opportunity to get full credit on a free response question as far as AP is concerned. Right? We state, plan, do, and conclude. We need to state what parameter that you're estimating, p, mu, whatever it may be, and at what confidence interval. Right? We need to plan. We're going to identify the appropriate inference method, one sample t interval for population. Sorry, guys. Stop it. Stop it. All right. Inference method, in this case, we're using the one sample t interval. And check conditions, random 10% normal large sample. Do, if the conditions are met, perform calculations. Right? Find the interval. And finally, conclude, interpret your interval in the context of the problem. Right? That is, these are the things we need to be able to get through this section. Is there any questions, anything I can clarify from these key concepts? Just in case, I'm putting the link to the Pear Deck in the chat one more time. Okay. We're going to get to our first question. This is a multiple choice question. Why t? One reason for using a t distribution instead of the standard normal curve to find critical values when calculating a level C confidence interval for a population mean is that, and use one of the 5 options to complete this sentence. There's only one correct answer from the 5 options. Read them carefully. In a couple minutes, we will talk about it. Alrighty. Looks like a lot of you guys had the opportunity to answer this one. If you did not, please make a guess real quick. All right. Based on the responses, it looks like a majority, or at least the most popular answer is the correct answer, so that's excellent. Let's look and see what it's supposed to be. Option B, Z requires that you know the population standard deviation. Okay. That's why we can't use the standard normal curve and we use our t distribution, because it allows us to estimate using the sample standard deviation. Is there anything I can clarify about this problem? All right, let's continue. Next multiple choice question, critical value. You have an SRS of 23 observations from a large population. The distribution of sample values is roughly symmetric with no outliers. What critical value would you use to obtain a 98% confidence interval for the mean of the population? You're going to have to use table B. Right? I believe this should be clickable for you guys. If it's not, I'm going to put the link here in the chat so you can look at a copy of table B. right, if you haven't chosen an answer, pick one. Take a guess. All right. You got a better opportunity of getting it right if you make a guess than just leaving it blank. This is a strategy for taking multiple choice tests. We need to practice that because that's how the AP exam is going to have. We're going to have some multiple choice. All right. Good news is the most popular answer is the correct answer. .508. And to see how this is gotten, we're going to consult OneNote here. So if you want to switch to the shared screen, the screen that I'm sharing, here is how we get to 0.508. Right? We have a sample size of 23, which gives us degrees of freedom 22. We consult the left-hand column for degrees of freedom, and we find 22. We follow that column over, and we go to the bottom of table B and find 98%. That's the confidence level that I wanted. Find the intersection, we get 2.508. So anything I can clarify about how to use table B? Then, here we go. Let's get to the next question. Quality control. A quality control inspector will measure the salt content in milligrams in a random sample of bags of potato chips from an hour of production. Which of the following would result in the smallest margin of error in estimating the mean salt content mu? There's only one correct answer. Consider how the confidence level and sample size can influence the variability, the variance of our distribution. Let's see where we get. Once again, the most popular answer appears to be the correct one. And we have the correct choice was B, 90% confidence with an N equaling 50. Again, this goes back to how your confidence level and sample size can influence the variance of your distribution. All right. And what we can do is we can look at how we calculate margin of error. Because if we're provided some sample mean, sample standard deviation, and we're using different confidence intervals or sample sizes based on that, the x bar and s sub x are going to be the same for all of these. Right? So the only numbers changing based on confidence and size of the sample, so to say, are those two numbers. A smaller critical value creates a smaller margin of error, because multiplying something by a smaller number creates a smaller result. And a larger sample size creates a smaller fraction here, which results in a smaller margin of error as well. And so between those two factors, right, smaller critical value, larger sample size, gives us a smaller margin of error. And so when we look at our table B, the four values we can actually identify based on the options we have, right? 1.684 is going to be the smallest T star value, right? And that goes with the N equaling 50 and a 90% confidence. We can't really choose the N equaling 100 for any confidence level because there's just too many options, right? Because yeah, I mean, if we choose 90% or less, that could work out. But if it's more, as far as our confidence level goes, it's not going to work. It's not going to give us as favorable as of a result. But also if we choose less, we have like no confidence. So we're not getting a very usable result. Okay. Is there any questions on this particular problem and the reasoning? So then let's do our next multiple choice question. Oh, never mind, it's not multiple choice. That was the last multiple choice. This one you need to write your response for. All right, so writers in some fields summarize data by giving X bar and its standard error rather than X bar and S sub X, or the sample standard deviation. Biologists studying willow plants in Yellowstone reported their results in a table with columns labeled X bar plus or minus standard error. The table entry for the heights of willow plants in centimeters in one region of the park was 61.55 plus or minus 19.03. The researchers measured a total of 23 plants. Find the sample standard deviation for the measurements. We can do this by setting up this equation. Standard error equals the sample standard deviation divided by the square root of n, or sample size. Solve that for S sub x. All right, so I know some of you guys might still be working on this. I'm not going to progress from this screen yet, so you can continue to type in responses. We are going to look at the work that goes into this one. So I'm going to switch over to my OneNote page. So if you want to follow along with the work that I'm going to show, please go to the shared screen. Also, I know that for some reason Pear Deck does not like the math rendering that I used in the Google slide. So some of those are being dropped out from time to time. If you look at the shared screen, so if you go to the other tab away from Pear Deck and look at the shared screen on Teams, you should be able to see the numbers if they are missing from your Pear Deck slide. I'm not sure why this is happening. I've done this before and it hasn't been an issue, but apparently this time it doesn't like it. So for this problem, we are given that the entry, from our researchers here is 61.55 plus or minus 19.03. Based on the format we were given, 61.55 is the sample mean X bar, and 19.03 is the standard error, SE. We have the formula. The standard error is the sample standard deviation divided by the square root of the sample size. So here's the numbers we need to use. SE equals 19.03, N equals 23, and that was also provided in the context. We had a sample size of 23. So we substitute in our values for the variables. We get 19.03 equals S sub x divided by the square root of 23. We multiply each side by the square root of 23. That cancels the square root of 23 on the right-hand side, multiplies it on the left-hand side, and we get 91.265 approximately centimeters is equal to the sample standard deviation, or S sub x. Is there anything about in this process that I can clarify for you or explain in better detail? All right, we're going to move on to the next question. Well, next slide, which is the solution. S sub x equals 91.26. And again, it seems like it doesn't like the rendering here, so you may or may not be able to see this, but if you look at the shared screen, it is showing. I do apologize about the technical issues that I'm having with Pear Deck today. So our last question, this is again more of a free response question. You're going to type in your solution below in the space provided. So a big toe problem. A bunion on the big toe is fairly uncommon in youth and often requires surgery. Doctors used x-rays to measure the angle in degrees of deformity on the big toe in a random sample of 37 patients under the age of 21 who came to a medical center for surgery to correct a bunion. The angle is a measure of the seriousness of the deformity. For these 37 patients, the mean angle of deformity was 24.76 degrees. The standard deviation was 6.34 degrees. The dot plot of the data revealed no outliers or strong skewness. And this detail is provided because we don't know what the parent population is. We want to construct and interpret a 90% confidence interval for the mean angle of deformity in the population of all such patients. So the response that you type in here should be essentially the conclusion part of your four-step process, meaning we are 90% confident that the interval from lower boundary to upper boundary of the interval captures the true mean angle of deformity in the population of all such patients. So a lot of you guys look like you're on the right track here. You're getting the right verbiage, right interval for this context and for this problem. So awesome job. Some of you guys I was able to give direct feedback to. I do apologize, I read kind of slow, and so I didn't get to everyone, but on a quick skim, it seems like a lot of you guys got to the same spots, which is awesome. So we're going to look at the work that goes with this. I'm not going to progress here, so if you're still completing your answer here, please continue to do so. And if you'd like to follow along with the work that goes into this problem, please look at the shared screen from Teams. All right, so on our big toe problem, I have outlined here the four-step process for estimating our population mean. Right, so we start by stating what we're going to do. We want to find mu equaling the true mean angle of deformity with a 90% confidence level. Our plan is if conditions are met, we will use a one sample t interval for mu. That's our inference method. We check our conditions here. Random, the patients were a random sample, so that's good. 10%, we can assume that 37 is less than 10% of all such patients. And when we're making that assumption, because that allows us to do this problem. And typically if they're going to provide us a problem where 10% condition is not met, they're going to give us the size of the population so we can actually do that percentage calculation and see if it works. And we meet the large sample requirements, n equals 37, which is greater than 30, so we can use a t-distribution. Next, we do the math. Right? We know what x bar is, it's 24.76. We know what the sample standard deviation is, at 6.34. For a 90% confidence with a degree of freedom of 36, right, 37 minus 1, we're going to use the degree of freedom on table B of 30, because that is the closest degree of freedom listed on table B that is not greater than 36, and that gives us a t-star value of 1.697. And again, we have an n of 37. We set up our interval calculation, which is x bar plus or minus t-star times sample standard deviation divided by the square root of the sample size. We put this in the calculator, we do subtracting the margin of error, we get 22.991 approximately. We add the margin of error and do this again, we get 26.529 approximately. Right? And so this is the interval. You need both numbers. Right? The smaller number is considered the lower boundary of the interval. The larger number is considered the upper boundary of the interval. It's our cutoff points. We then can write our conclusive statement, which is what you guys were typing in to Pear Deck. We are 90% confident that the interval from 22.991 to 26.529, and I should have degrees in here. That's a error on my part. Captures the true mean angle of deformity in the population of all such patients. You can also kind of flip the order in this and say we are 90% confident that the true mean angle of deformity in the population of all such patients is between 22.991 degrees and 26.529 degrees. Both of those are correct. is there any questions or anything I can clarify about this problem and how we go through the process? Again, I want to highlight using the 4-step process. It is our roadmap to make sure we don't skip any steps. And it helps us get full credit on AP questions. All right. So then that's the end of the Pear Deck and the end of Chapter 8. Right, so I'm going to find my, yeah, good. So we're going to look at the course here real quick, just so I can show you guys what we have available here for Chapter 8. If you haven't been looking into the course and looking at the modules, Chapter 8 is pretty much totally published. I have the multiple choice questions, multiple choice assessment ready to go. The free response questions should be posted in the next hour-ish. I'm just finishing up typing it up. And the questions on the free response questions are ones that I wrote, so they don't exist out there in the internet yet. If you look at the resources, right, there's tons of stuff in our resources here, especially for 8.2 and 8.3. There is a bunch of AP Daily videos. Those are a lot of good examples. So if there's something you're not clear on, watch one of these videos. A lot of information there. There's a bunch of examples in the textbook that we have videos on here. There's also some calculator tips and tricks that you can use, right? Calculating a confidence interval for a population proportion, right? Our Z interval, T intervals for mu on the calculator, inverse T on the calculator, right? Gets that T star value from table B on using your calculator, right? There's some very useful things here. So don't forget about the resources that I have available here. There's a lot of good stuff. And then the practice problems and solutions are all available for all 3 sections in Chapter 8, but also it gives you a quick review of the kind of like things, the formulas and ideas that are most important for that section. And so it's beyond just the problems, you get some extra stuff to study with, so to say. So don't forget about those resources, okay? They're all here to help you. So make sure you're using them. The Pear Deck activity will be added here later. I don't have that one in there yet. Yeah. So that leaves us with what's remaining for Chapter 8 is the assessments. The due date on those, and remember, due date is a loose term here, I have set for March 8th, and that's just to pace, right? So that you have an idea of when things could or should be done to keep up with everything going on in the class. Other than that, if you have any questions, comments, concerns, please feel free to stick around after the end of class here and talk to me about it, or send me a message later, email, on Teams, something. And that's all that we have for today. You know, enjoy the rest of your week. Hope you have a great rest of your week. You have a great weekend, and we'll see you on Monday next week for the T lesson. And that's it. We've done it.